Alright, this video we are going to focus on the ideal gas equation or ideal gas law, and that is what I like to call PVnRT. P times V equals N times R times T. So what we have here, breaking it down, we have P, which is pressure, we have V, which is volume, we have N, which is number of particles, we have R, which is new to us. R is going to be our gas constant. I'll talk a little bit about that at the end. And T, of course, is temperature. So this ideal gas law is basically if we had a perfect gas that acted exactly like we predict that it would, we would be able to use this equation to predict any of and calculate any of these 5 variables. We do have one in here, R, which is the gas constant. You're going to learn a little bit about that on the next slide in your PowerPoint, but very, very briefly, scientists were discovering and exploring gas laws and how gases interact with each other. They discovered that there was a number that they needed that tied in the proportion between pressure and volume and number of particles and temperature. They kept getting the same number. And that number that we're going to use for us is 0.0821. And the units for this is kind of crazy because it has to tie in all 4 of these other units because it's the constant that connects them all. So it's actually going to be liters times atmosphere divided by moles times Kelvin. That whole thing is the unit for the gas constant. So it's a big unit, but basically what we have here is pressure times volume equals number of particles times gas constant times temperature. The main reason for this video is to talk about what the ideal gas equation is, and also to show you how to rearrange it for given variables. So let's just pretend we are doing a question and we have some variables like this. Now notice this unit matches all of the other units. When we solve for pressure, it's going to be an atmosphere, so it matches our gas law. So whenever you solve for something, your unit is going to be inside the gas constant units. So if we're going to solve like this, we can do it 2 different ways. You can either keep your equation together and just plug and chug. I guess the only one that I think I would be okay with you guys kind of slacking on the units is the gas constant, because that's a lot of units in there. So I think I'd be okay if you miss that unit, as long as you know what it is, because you need to know liters for volume, blah, 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 pressure, ATM. You need to know what those are. So this first method is just plug and chug, plug in your numbers. That way you can multiply all of your numbers together. So 3 times 0.0821 times 300, that's 73.89. Then we have this P times 12 liters equals 73.89. If we want to get P by itself on this side, we have to divide both sides by 12, and we end up with a pressure of 6.16 atmosphere, because it is pressure and our gas constant includes atmosphere. Okay, that's one way that you can do it. Call it my plug and chug, because you literally just plug in numbers to the equation. Or you can rearrange your equation first and then you can plug in numbers. So PV equals nRT, PVnRT, we always start with that. We want pressure by itself. So because we're multiplying these 2 together, they're next to each other. If we want P by itself, we have to undo that multiplication. We have to divide both sides by volume. That cancels and gives us P equals nRT divided by volume. And from here, you can plug in your 3 moles, your gas constant, your temperature, and notice how it ends up being the same exact answer. Either way works, but I want you to pick one way and I want you to stick with it. So if we have to rearrange this equation to solve for all the other variables, we end up with nRT divided by V. If we want to solve for V, get V by itself, we have to get rid of P, pressure. Do the opposite, divide both sides by P. nRT divided by P. If we want to get N by itself, number of particles, this time we're going to focus on this side of the equation. And we're going to divide by R times T. That way I can cancel out both of these, because it's all being multiplied, so we divide opposite by both sides. So we end up with N equals P times V divided by RT. And same idea goes for R. If we want R by itself, we're going to divide by N times T. Get those guys out of the way. And temperature, again, get rid of the ones that are stuck to it through division. Temperature is pressure volume divided by nR. Really, the only one you need to know is PVnRT, this one. And then from there, where you rearrange it first. But again, if you prefer the plug and chug method, where you have PVnRT, you plug it in, you solve for your unknown, you're good.